Find the area bounded by a given curve. So sine cubic x. So let me just draw the sine curve first. Okay, so note that at pi over 2, it's going to be 1. If you raise 1 to the power of 3, it will stay at 1. If you cubic, right, negative 1 to the power of 3, you will also stay at negative 1. However, all the other numbers, right, all the numbers that are from 0 to 1, if you cube it, it's going to get smaller. So it'll depress like that. Okay. This is just an approximation. This is not, the picture for this. But I don't need to draw an accurate picture. What I was asked to do is to find the area, right? So cosine of cubic x. Okay, again, approximately it looks like this. Let me just draw the normal one first. It's just going to, right? It's just going to depress, okay, like that. Okay, so we want to find the area from pi over 4 to 5 pi over 4. Okay, so pi over 4 and 5 pi over 4, that's exactly actually where they're going to intersect. Okay, so let's actually make these two equal to each other. Sine cubic x is equal to cosine cubic x. So if you divide both sides by cosine of cubic x, we get this is equal to 1, which is a tangent cubic of x is equal to 1, which means tangent of x has to equal to 1. So when does tangent of x equal to 1? Well, clearly pi over 4. But the one after that, it's exactly pi plus pi over 4, so it's going to be 5 pi over 4. So see where, okay, the two blue graphs here, right there, that's pi over 4. And right there, that's going to be 5 pi over 4. So we're talking about finding the area, this area right here. Okay, that's what we're talking about. So from pi over 4 to 5 pi over 4, you can see that this, which is a sine curve, the sine cubic function, is above and the cosine is below. So the area setup will be, right, integrate from pi over 4, 5 pi over 4, okay, and the sine cubic x minus cosine cubic x. Alright, so how do you integrate this? So let's actually first factor out. Okay, let's factor out. Let's factor this. This is a cubic, differences of cubes, and that factors into this: a minus b, a squared plus ab plus b squared. So we get sine of x, cosine of x, right? Sine squared x plus sine of x, cosine of x plus cosine squared of x. Alright, so that plus that will give you 1. So we get 1 plus sine of x and cosine of x. Alright. Okay, now let's distribute this. Okay, let's distribute this. So we get sine of x, and then next you get sine squared x cosine of x, and then you get a minus cosine of x, and then you get a sine of x cosine squared x. Okay, so these two are very easy to get the antiderivative of. There's a simple one. It's going to be a minus cosine of x for that one. Okay, that right there is going to be minus sine of x. Okay. Okay, so these two, let me just actually leave it an integral for now. Okay. So here you have to let that right there equal to u. Okay, so cosine, let's say x equal to u. You get minus sine, oh sorry, the other way around. Okay, you have to let sine of x equal to u. Then you get cosine x dx equals to du. Okay, so cosine times x dx equals to du. Okay, so we're gonna get a u squared, this is all going to be du. Okay. Here you have to let, you have to let the cosine of x equal to, let's say, v, the minus sine of x dx equals to dv. Okay. So we're gonna get a minus, right? Because sine dx, right, is going to, okay, let me just highlight that, sine dx is going to equal to minus dv. So minus dv with v squared there, v squared. So minus cosine of x minus sine of x plus a third u cubed minus a third v cubed. Okay. Let's all replace in terms of x. So u was sine and v was cosine. Now we gotta put in, okay, 5 pi over 4. So that's 5 pi over 4 there. 5 pi over 4 and pi over 4. Alright, so cosine of 5 pi over 4, that's going to be a minus, okay, a minus 1 over root 2. Sine also is going to be minus 1 over root 2. Okay, so if I do this one right here is going to be a minus 1 over root 2 cubed, okay, minus 1 over root 2 cubed again. Now minus, now we're going to plug in pi over 4 now. Pi over 4 is just going to be 1 over root 2. So minus 1 over root 2, another 1 over root 2, right, 1 over root 2 cubed. Okay, and lastly also 1 over root 2 cubed. Okay, so let's simplify. That becomes 1 over root 2, another 1 over root 2. Okay, and that right there becomes a minus, right? Minus, if you cube that, you get 2 times root 2, so it's 1 over 6 root 2. Okay, so this is going to become plus 1 over, again, same thing, 6 root 2. Okay, so that's kind of nice because that'll actually cancel out. Okay, at the bottom, if I actually distribute that negative, I get a plus 1 over root 2, another plus 1 over root 2. Okay, plus this becomes again a 6 root 2, a minus 1 over 6 root 2 again. So these two cancel out again. Okay, so we just have exactly 4 of those. So it's going to be 4 over root 2. Okay, and you can multiply top and bottom by root 2 to get 4 root 2 over 2, which is the simplest form, 2 root 2 for the area.